So for multiplications, if you have a over b times c over d, if you have two rational expressions multiplied together, then you just multiply the numerators together and the denominators together, and you should get a times c divided by b times d. Again, because we are dealing with fractions or rational expression, the denominator cannot be equal to 0, so we impose the conditions that b is different from 0 and d is different from 0. For divisions of rational expressions, you do a over b divided by c over d. When you divide fractions, you can rewrite it as multiplication of the reciprocal. So a over b times the reciprocal, and you get d over c. And then from here, you can just do multiplications, right? So the top multiply together, the bottoms multiply together. So AD divided by BC. Now for division, it's a little bit tricky when you impose the conditions. So let's take a look at the fractions that we have. You have one fractions, another fractions, and the fractions right here, okay? So B has to be different from 0, D has to be different from 0. You okay with that? And then when because of this division, you multiply by the reciprocal. Now you have the third condition, that is C has to be different from 0 as well. Here, you impose that B different from 0, C different from 0, and D is different from 0. For canceling again, well, I have mentioned this point earlier that you have to find the conditions before making any cancellations. Okay, find the conditions of the denominators before making any cancellations. When you want to multiply two rational expressions together or divide two rational expressions, you can follow these steps, right? So I assume that, make assumptions that nobody has seen this material before, therefore this procedure, okay? But if you have done this material before, you're familiar with the process, your own process, just follow your own process, okay? So this step adjusts my assumptions that nobody has seen this. You good with me? If you've done this before, if it works for you, just follow your lead. Okay. Okay, but let me go over this step a little bit. So the first step, when you have the rational expressions, factor the numerator and the denominator when possible. Okay. Then cancel all the common factors. Then multiply the numerators together and denominators together. And if you have the divisions of rational expression, you multiply the reciprocal. Okay. All right, so let's start with example 3 and see what happened. Given these expressions, I'm going to do a simple simplifications that just find the common factor on the numerator. So here's what you get. So x is the common factor on the numerator. You have x minus 2. And 3 is the common factor in the denominator. So x minus 2. 3 is different from 0, obviously. We impose the condition that x minus 2 is different from 0. So this implies that x is different from positive 2, and then you can make the cancellations, and you get x over 3. Right, move on to B. Now it's really the rational expression by one another. Right. So factors the numerator and denominator when possible. So let me start with this problem by factoring. Right, so x squared plus 5x minus 6 can be factored into x plus 6
x minus 1
divided by 12x. Now you multiply by the reciprocal. Impose some conditions here. So x different from 0, x plus 6 different from 0 implies x different from negative 6, x minus 1 different from 0, x different from positive 1. Now simplify. So 12 and 4 cancel out. So this is 1 times, this is 3 times. The x cancel out. Then that's it. Nothing else. You'll have it on the numerator is 3 times x minus 2. And in the denominator, you have x plus 6 times x minus 1. Right, in the next example, it's the same thing. Right, you have divisions of rational expressions. So factor when possible. So I have x plus 3 divided by x minus 2 times x plus 2. All together divided by
x minus 4
times x plus 3 over x minus 2 times x minus 2. Now rewrite this. Right. Divide a fraction, that means you can multiply by the reciprocal. So you have x plus 3 divided by x minus 2 times x plus 2 times x minus 2 over x minus 4 times x plus 3. Conditions. So here you get that x minus 2 different from 0 implies that x different from 2. X plus 2 different from 0 implies that x different from negative 2. X minus 4 different from 0 implies that x different from 4. X plus 3 different from 0 implies that x different from negative 3. Now you can make cancellations. So x plus 3 cancel out. Then x minus 2 cancel out. And you're left with the numerator is just x minus 2. The denominator include x plus 2 times x minus 4. All right, let's move on to the next example. Again, you have two rational expressions multiplied together. First, factor the numerator and denominator when possible. So the x squared minus 2x plus 1 give me x minus 1 times x minus 1 over x times x squared plus 1. So in the denominator of the first rational expression, you have x as a common factor. You take out the x and you left with x squared plus 1. Multiply with the second rational expressions. On the numerator, 4 is a common factor. And the denominator can be factored into x plus 2 times x minus 1. Next step, condition. So x different from 0, x plus 2 different from 0, implies that x different from negative 2. And x minus 1 different from 0 implies that x different from 1. Then cancellations. So x minus 1 cancel out. Then x squared plus 1 cancel out. And you're left with 4 times x minus 1 divided by x times x plus 2. So in the next two examples, can you do it yourself or you can talk with your friends if you want to? I'm going to give you like 15, 30 seconds and we're going to walk around and look at your work. Okay. So try to factor the numerator and the denominator when possible. So I have x plus 4 times x plus 3 divided by x minus 4, x minus 3, all together divided by x plus 4 times x minus 3 over x minus 4 times x plus 3. So you divide a fraction, that means you can multiply by the reciprocal. So x plus 4 times x plus 3 over x minus 4 times x minus 3 times x minus 4
times x plus 3
divided by x plus 4 times x minus 3. Okay, next step is conditions. So here for x minus 4 and x minus 3, you do x minus 4 different from 0 implies that x different from 4. X minus 3 different from 0, x is different from 3. This condition, x minus 4 different from 0, we already got that, so we can ignore it. X plus 3 is different from 0. So you get x different from negative 3. And move on to the last denominator here. X plus 4 is different from 0, x minus 3 different from 0. But we already got x minus 3 different from 0, so we good. Okay. Now, next step, cancellations. X plus 4 cancel out. X minus 4 cancel out. And we left with x plus 3 times x plus 3 on the numerator, divided by x minus 3 times x minus 3. Right. Then for short, combine two terms together. This is what you get. Now for D, again, you factor the numerator and the denominator when possible. So this is what I got, x minus 5 times x plus 2 over x plus 7 times x minus 5. That's for the first rational expressions. The second rational expressions give me x plus 7 times x minus 3 over x plus 7 times x plus 2. Now conditions. So x plus 7 different from 0 implies x different from negative 7. X minus 5 different from 0 implies that x different from 5. Then x plus 7 different from 0, but we got that already. So we good. Then one more conditions, x plus 2 different from 0 implies that x different from -2. Next step is cancellation. So x plus 7 cancel out. Right. For this one, you can cancel this x plus 7 with this x plus 7, or this x plus 7 with this x plus 7. You follow the idea, got it? It's the same thing. Now x minus 5 cancel out. And one more x plus 2 cancel out. And you're left with x minus 3 over x plus 7.